Hello everyone, welcome back to the session number 2, and today we are going to discuss about the fundamentals of brake. First of all, I would like to inform you this is going on only static session. Static means we will not discuss about the forces and the effect of forces, basically that we will discuss in the dynamics part. So today's session is about the brakes. So first of all, let us understand what is exactly brake. What is exactly brake? So what is brake? These are the mechanical device. Which one? This is a mechanical device. You can also set connection of linkages. Connection of linkages. Used to convert kinetic energy into heat energy via friction. So we will understand how this function is going on, basically the conversion of kinetic energy into heat energy. That is the core function of braking system. So from here we can understand that the principle of braking system is basically, आप ऐसे लिख सकते हैं, समझ सकते हैं that principle of braking system, BS means braking system, is depends on the principle of conservation of energy. Principle of conservation of energy. So this one is very important point. Note it down. So the principle of braking system depends on the principle of conservation of energy, and that is what? Okay, in this particular thing, the kinetic energy of vehicle, of any object, is going to convert in heat energy by the friction. So brake systems are basically the mechanical linkage as a device which are converting kinetic energy into heat energy by means of a friction. Understood? Okay, let's move ahead. And now we will understand the function of brakes. What are the different function? What are the different function of brake? So here we will understand the 2-3 functions. The first one is to stop the moving vehicle in the shortest possible time. See, during the driving, what we expecting? During driving, what we expecting? We are expecting when we applied brake, the vehicle should stop at shortest possible time, and also at shortest distance. That means what we can understand, the functions is what? Stopping distance should be minimum. One function of brake is what? Stopping distance. We can say we are expecting a stopping distance should be minimum. should be minimum, no problem at all. And second one, and also the time is required time is also very much less. And second one is what? To help the controlling the speed of the vehicle during the cornering. Suppose we are moving at the road like this. So during the cornering, the braking system help us to reduce the velocity of the vehicle. So this was controlling the vehicle, reduce the speed at turning and other crowded places. To hold the vehicle in its stationary position without the pressure of operator after it has been brought to a stop. Again, very important point. Okay, if you are in motion, so the brake system is help us to vehicle to stop the vehicle, So this system is held in its stationary position without the presence of the operator. So these are the basic three functions of brake: to control the vehicle, to stop the vehicle, to slow down the vehicle, like that, and to stop in possible less time and less distance. Fine. So let's move ahead. So suppose we are going to design a brake. We are going to design a brake. So if we are going to design a brake, what we are looking? The expectation from a designer. So the brake should stop the vehicle within a reasonable distance. See, if a driver see the object in front of him around 5 meters, so what the driver can expect? Even in 100 kilometers per hour, so driver can expect the vehicle should stop within 5 meters, less than 5 meters. So what the brake should stop the vehicle within a reasonable distance, and the retardation shall be smooth, free from jerk and shudder. It is very important. If we are going to apply the brake, and it is operation of brake should be smooth operation. Smooth operation is very much important. After application of vehicle should not transfer jerk. Should not transfer jerk. So this is also the like a combination of the combined function of, I'll say this is combined function of just a minute. I'll say this one is the combined function of brake and steering. Suspension. So this one is a combined function of brake and suspension to reduce the jerk during the braking. This cannot be done with the braking components and all. Majorly this work is what? Given by the suspension. Second one, see, important point is what? Stopping distance. Stopping distance should be minimum. Time should be minimum. Stopping distance and time should be minimum as much as possible. And also the very much important, which I did mention here, that is what? Should be safe. I will say safe stopping distance. That means after application of brake, there should not be any kind of unbalancing of vehicle. This one is very much important. Okay, stopping distance minimum and safe. Stopping distance minimum, and you can mention minimum and safe. Again, this one is important point, minimum and safe. See, so we understand the second point also. The first point, the second point is the braking system should be very reliable to promote highest degree of safety on the road. This one is important. That's why I explained that the stopping distance should be minimum but safe. Okay. So if any braking system is giving us the very less stopping distance, but it is not safe, the balancing of vehicle during the braking is not safe, so this is not acceptable. So the stopping distance should be minimum, but it should be safe also. So let us understand the third point. The braking system should not be affected by water, heat, road grit, dust, etc. Again, if you have designed something, some kind of brake, and installed to in your EV, electric vehicle or any vehicle, so what is the expectation from the brake? It should not be affected by water. What does it mean? Suppose this one is a disc, caliper is here, caliper is mounted here. So in rainy season, what will happen? The disc will be wet due to the raining. So that should not cause an accident because of slippage and all. So we will understand how we can avoid this. So that slippage should not be there. Because of heat, there should not be much expansion in disc or braking component. So should not be affected by water. Should not be affected by heat. Road conditions means, suppose if you are driving the vehicle on sand, so braking should not be bad. That means effective braking system is required there, if required, necessary. Second one, if we are moving on a stone road kind of thing, or modern RCC, so that means the braking efficiency should be maximum here also, max efficiency. If you are moving on like a village area, soil kind of road, so there should be also the braking efficiency should be better. That means the effectiveness of brake should be maintained in all condition. What point we can mention? Just a minute. We can mention here the effectiveness of braking system. Here we can write the effectiveness, we can write here the effectiveness of braking system should be maintained in all conditions. In all conditions. So that is all about the third point. Fourth one, pedal effort applied by the driver should not be more so as it not strain the driver. देखिए, in previous time, you will check before 30 years, 40 years back, so the force required to apply the brake, it was much higher. Even driver feels tired after the driving vehicle even only 1 hour, half an hour or 2 hours. So just understand the condition of bus driver or truck driver before 20, 30 years or 40 years. So the required force, what we can write, the required force should be minimum as much as possible. So यहाँ पे हम लोग we can write the required force by driver should be minimum. Should be minimum. required force by the driver should be minimum. Important point, very much important, this one and this one, like, so during the designing a brake system we should keep these points in our mind. If we are skipping this first one, second one, third one, fourth one, that means we are not going to design a good brakes. So brakes should work equally good in all weathers. अब ऐसा नहीं हो कि ठंडी में कुछ और इसका रिएक्शन चल रहा है, गर्मी में कुछ और, बारिश में. दिस इज अ डिफरेंट काइंड ऑफ बिहेवियर इन डिफरेंट वेदर इज नॉट एक्सेप्टेबल एट ऑल. So the behavior of braking system or a vehicle should be good. Number 6 point, the wear and tear of the material of brake linings, minimum and longer life. See, the selection of material for a brake or a clutch should be very good. Like, due to the friction, a large amount of heat is generating. Suppose this one is disc. So because of friction, huge amount of like heat is generating here. So material should be very good. The strength should be very high, so that it can maintain the effectiveness. Or tear wear should be minimum. Tear and wear should be minimum. You can write here. Otherwise 6 months we need to change the disc or a pad every 6 months, 3 months, 2 months. This will be very, like, a maintenance of vehicle will increase if the material of braking system will not good. So 6 point is covered. Now think about the 7 point. Due to the rubbing action, the brake shoes along with lining against drum, large amount of heat is generated due to friction. The brake design system should be capable of dissipating the heat very quickly. Again, this one is very important point. So I already explained what will happen when brake shoes will act at particular these areas. So because of generation of heat, high amount of heat, the temperature of the disc also will increase. Even the temperature in 600 degrees centigrade, 700, 1500 at instant time. So the material of this should be the capable of continuously, rate of dissipation should be very high. क्या point है? Rate of heat dissipation. Heat dissipation should be very high. Should be very high, है ना? Rate of heat dissipation should be very high. So this one is again important function. If this function is not working properly, so the disc will cause the expansion in their radius in terms of radius or area. So disc will expand. Because of expansion, so maybe the seizing of the brake components. Let us understand the 8 point. All the components and lever and the brake system should be strong enough to take the mechanical stresses and strain which are encountered during the brake actuation. So this one is very much important. After application of brake, I'll take another page for just a minute. We'll come on this. Let us understand here what will happen. Suppose this one is a brake. See, disc, you can say this one is a kind of disc, and here you have taken a brake pedal at this point. So this one again a kind of lever 1, lever 2, we are calling it L1 and L2. Just see the basic construction of brake system, how it is working. So this one is consider the hydraulic cylinder if it is kind of hydraulic brake. So let us consider. So inside cylinder there is a piston, that is also okay. This is a hydraulic pipe going on. Hydraulic pipe, and this is connecting to hydraulic pipes. Suppose it is moving in this way, and I am going to connect this one like this, something like this. So this one is what? Cylinders and pad at this side, and this side also you can say this one is the cylinders and pads are here. So what will happen when you will apply the force? Certain amount of force here, driver will apply. This one is called pedal. What does it call? This is called pedal. This is called linkage or lever, you can say. This one is lever, and this one is cylinder. This one is called brake pipe. This one is called caliper. I just designed a fundamental basic design of a brake system. This one is called caliper cylinder. Caliper cylinder. And consider this one is a disc. This is the center of disc, and this one is a disc. Okay. So also you can you can understand by drawing something like this. In this way, so we have designed the system like this. So gripping will be in this side something, and this one is the center, you can say this one is the center. A disc is operating at this point. So what will happen here? If driver will apply the force at this point. So this is a what force? This is like a, you can say this mechanical one purely. And this force, suppose this applied 120 Newton something force is applied here. So this force is coming down with the help of these levers, lever L1 and L2. So we'll understand the lever ratio also. Which one is lever ratio is very important. So this is more than one, lever ratio should be higher. Like if more than one, so you will get a more moment of force. So this will help in actuation of force. This is also transferring and actuating the force. What will happen? This force will transfer to this particular cylinder, hydraulic cylinder, with the help of these levers. Okay. So this force will now, in this cylinder, this force is acting on per unit area. So will produce a pressure. So now the pressure at this particular point, you can see, so the pressure will be force upon area. This area is what? Area of cylinder, cross sectional area of cylinder. The effective area of cylinder, you can say effective area of cylinder. So you can calculate the pressure of cylinder after application of certain amount of force. So this particular pressure now, because of there is a hydraulic fluid, we'll discuss the property of fluid also. But let us understand. So this pipe is completely filled with the hydraulic fluid, completely filled with the hydraulic fluid, like this, up to this point and this point, completely filled. So when the pressure will develop here, that pressure will transfer with the help of these pipes and fluid to the caliper. And the pressure, by the way, I would like to tell you the pressure at this point. Which point? The pressure at this point, that means P, pressure at P cylinder, I light P cylinder, is equal to the P caliper. you can like the pressure at cylinder will be equal to the pressure at caliper, because we are considering that there is no loss of pressure from here to here. Understand? So now this pressure will transfer to the here calipers, both side, maybe the single acting, maybe double acting calipers, single side or double side. So what will happen, that will apply the pressure here again, and this pressure, suppose if this is a like a pad, any kind of pad like thing, and if hydraulic pressure is acting on this, so what will happen on a caliper? So this will, there is a cylinder kind of thing, like one cylinder is there and other cylinder is there, and the pressure is acting on the cylinder. What will happen, this this will move in this side, so this brake pads will come into the contact of this particular disc. So this pads will come into the contact with this disc. So again this pressure is converting into the force here. So pressure again will convert into the force. Not equal though, don't understand this. I am saying the pressure is converting into force again. So this particular pressure is converting force. That force is acting here as a frictional force. How it is acting? Acting as a frictional force. So this one is going to be important to understand how the force is traveling from paddle to cylinder, cylinder to brake fluids and pipe, from here to caliper, caliper 1 and caliper, we are calling it, see, we are calling it caliper 1 and caliper 2 something. See, understand, this is called caliper 1, and we are calling it caliper 2. So part 1 and part 2, the pressure is acting both side. So that will generate the force actually here and here. So that force is multiplied by 2 times force will be there. So this force which is acting on disc basically with the help of pad is called the frictional force. So I'll say if you have any doubt up to this point, so we'll arrange the a special kind of doubt clearing session. We are calling it DCS. So this doubt clearing session will help you. So you can message in your respective training groups or comment there, so that we can arrange this particular doubt clearing session if required, because I'm trying to give the best thing, so that like trying to avoid the doubts where students are generally or candidates are generally asking the questions, the points I am considering already here, because in offline classes we observe the number of questions, so we are trying to answer here like how the this particular things are operating are going on. Okay, so up to this point, is it clear everything? Now what we understand, let us go on, consider another page. See here, so brakes are basically brakes we are classifying in majorly 2 categories here: disc and drum. Disc brake and drum brake. And clear one thing, the actuation system may be different. The actuation system differs, आप ऐसे लिख सकते हो, like it may be mechanical, maybe hydraulic, maybe electronic, maybe Pneumatic, maybe pneumatic brakes, maybe air brakes, but understand the ultimate thing ki how the force is converting into the friction. So that is maybe that this drum or maybe this kind of disc. So in order to understand, we are calling it the hydraulic brakes, also we are calling it like drum brakes, sorry, in hydraulic brakes we are calling it power brakes also, power brakes also. So we will understand ki what is the like actually the power brakes, electronic brakes, mechanical. Pure mechanical means we are going, the actuation systems are mechanical linkages. Mechanical means mechanical linkages. Mechanical linkages. Mechanical linkages. So, and if you are talking about the hydraulics, that is what about application of cylinder and fluids. Hydraulic means just to generate the effective braking system, nothing else, just to generate the effective braking force. So every system have their specific, I'll say specific advantage. So we will understand one by one, and also we'll understand what is the basic things are like differences in drum brake and disc brake, which one is cost effective, which one is more efficient. What will be our target point? Target point I'll explain in next page. Goal, what we will call it goal. Our goal will be how to, you can note it down, how to increase the efficiency, of braking system. This one will be our ultimate goal. After understanding and learning what is exactly brake, so we will focus here how to increase the efficiency of braking system. See, efficiency of brake system means what? So you should recall the requirement of good braking system. That means stopping distance should be minimum and safe. Time should be minimum. So that means how we can decrease the this one. And also you can say like the for required force should be very less. How we can decrease the required force? Required force should be very less, should be less as much as possible. See? Okay. So these are the things where we will focus, and then after we will design some good kind of brake system for our vehicle, for our bike. What we will design in our hands-on training during the like in last 2 months. So let us move ahead after this. Try to understand exactly okay, what are the components of brake. What we will understand now, components of brake. Components of brake, first one will say the brake pedal. Which one? The brake pedal. Every design of every component is very important. Brake pedal design is also important. Second one, levers. Third one, master cylinder. Fourth one, brake fluids and pipe. Fifth one, caliper and pads. Sixth one, disc. See, tire is going to also play a very important role in braking, but here I am not discussing because tire is not a part of braking system. Okay, exactly, because the manufacturing and other thing of tire is very different at all. So we are not going to like think about now. But during the calculation of brakes, we will understand the role of tire also. The tire role of tire in braking system. Okay, so because in offline batch we are discussing the things in very detail, so that's why currently we are running we are not covering the much course in a one day, but slowly as my tuning will be better with the participants, so definitely the course will go ahead very fast. So so today in second session this is all about, and in third session we'll meet again. Thank you so much. Good luck.